Okay, so another similar scenario, except now we're going to include friction between the mass and the incline. So question would be, or would include, having to find the acceleration of the mass down the incline. So we're going to assume that if there is any acceleration at all, it'll be in that direction. And how would we calculate that? Well, we'd have to find the net force acting on this thing. So in part, there's a component of gravity going this way, and we've already done problems like this, and it works out that this is mg times the sine of theta. And there's the other component perpendicular to the surface turns out to be also the normal force. And the normal force, which we're going to need to calculate the friction force, the normal force is mg cosine theta, as you will recall. And so the friction force, which is going to be working up incline, opposite the motion of the mass. So the friction force is equal to the coefficient of friction, and let's say it's moving, so it's kinetic friction, times the normal force, which gives us mu k times mg cosine theta. Okay, so basically, it's still not going to be accelerating perpendicular to the surface. It's going to accelerate parallel to the surface. So that acceleration, using Newton's second law, is equal to the net force divided by the mass. And the net force, well, if it's going to accelerate down incline, then mg sine theta is in the positive direction. So that's mg sine theta. In the negative direction, so we're going to subtract it, is mu k times mg cosine theta. And all of that is divided by the mass. Well, we can factor mg out of both terms in the numerator. So we have mg times the quantity of sine theta minus mu k times cosine theta, all of that over m. And these two m's divide out, so we end up with g times the quantity sine theta minus mu k cosine theta. There you go. That's going to be the acceleration. And then you can calculate velocities or distances or anything else you want.